Hey guys, tonight, we're going to gently explore a question that feels as vast and empty as space itself. We're going to sit here in the quiet of our own little corner of the cosmos and imagine a cosmic event so profound, so cataclysmic, it could change the very nature of reality as we know it. I'm talking about a collision of universes. But let's be honest, you and I, we probably wouldn't survive it. We're just two small specks of dust after all, and the forces at play would be far beyond anything our minds or our atoms could possibly comprehend. So before you get too comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, maybe you can share where in the world you are and what time it is there right now. It's a nice thought, knowing that we are all in our own way, floating in this cosmic ocean together. Now let's begin our story. Let's imagine the universe as we know it. This vast, intricate, beautiful thing we call home is not the only one. What if out there in some dark corner of cosmic possibility, another universe is hurtling towards us? An echo of two beginnings. We begin with the stillness of the cosmos, contemplating the Big Bang and the possibility of other universes born from different cosmic seeds. When we look up at the night sky, we see a tapestry woven from the light of billions of stars, the soft ethereal glow of distant galaxies, and the deep silent blackness in between. We see our universe as a singular entity born from a singular event, the Big Bang. But what if this great cosmic birth was not unique? What if it was just one of many a single bubble forming in an endless frothing cosmic sea? The idea of a multiverse of many universes existing side by side is not just a flight of fancy for science fiction writers. It's a concept with real theoretical underpinnings, a whisper in the calculations of our most brilliant physicists. Think of it like a pot of boiling water. Each bubble that forms and expands is a universe, a self-contained world with its own set of rules, its own physical constants, and its own unique history. Our universe is just one of those bubbles. It has been expanding for 13.8 billion years, cooling and coalescing from a hot, dense state into the complex, beautiful structure we see today. But what if another bubble, another universe, was born right next to ours? What if it also expanded, driven by its own cosmic forces, and began to drift inexorably towards us? The first question that comes to mind is, of course, what would this other universe be like? Would it be a mirror image of our own, with different versions of ourselves, living slightly different lives? Or would it be something so alien, so fundamentally different, that we wouldn't even recognize it as a universe at all? The truth is, we don't really know for sure. The very idea is a profound mystery. But we can speculate. We can use the tools of science and the poetry of our imagination to paint a picture of this cosmic stranger. Perhaps its fundamental forces are different. The strong nuclear force that holds atoms together in our universe might be weaker in theirs, meaning stars and planets could never form. Maybe their version of gravity is more powerful, pulling everything into a dense, inescapable singularity. Or perhaps the reverse is true. Maybe their universe is a diffuse, gaseous expanse where matter can never quite find a way to clump together. The possibilities are endless, and they are beautiful in their strangeness. They remind us that the rules we take for granted, the laws of physics that govern our every breath, are not necessarily universal. They are simply the rules of our little corner of the cosmic playground. But for a collision to happen, these two universes, these two cosmic bubbles, would have to be expanding towards each other. This brings us back to the Big Bang. The prevailing theory is that our universe began as an infinitely hot, infinitely dense point, and then, in a fraction of a second, it underwent a period of rapid expansion called cosmic inflation. This inflation stretched the universe far beyond anything we can comprehend, smoothing out irregularities and planting the seeds for the galaxies we see today. But what if there was another inflationary period, another Big Bang that happened in a different part of the cosmic void? What if these two inflationary bubbles, these two nascent universes, expanded not away from each other, but towards each other? The boundary between them would be a fascinating place, a cosmic frontier where the laws of two different realities would meet. It would be a place of unimaginable energy, a place where matter and energy from both universes would crash together, creating a spectacular, violent display. Imagine two massive waves, born from two separate storms, rolling across a vast ocean. They have been traveling for eons each, with its own rhythm, its own power. And then one day they meet. The collision would not be a simple crash. It would be a merging of energies, a superimposition of their forms, creating a single towering wave of unimaginable force. This is a very rough, very human-scale metaphor for what a universe collision might be like. The waves in this case would be the very fabric of space-time itself. The storms would be the Big Bangs, and the ocean would be the larger metacosmic reality in which both universes exist. What would this collision feel like? Would we even see it coming? Probably not. The cosmic scales are so vast, so mind-bogglingly immense, that the collision would likely happen faster than the speed of light could carry us the news. We would simply be there one moment in our familiar universe, and then in an instant, we would be gone, swept away by the forces of the cosmic tsunami. Let's go back to the idea of the other universe being different. What if it was a universe made not of matter, but of antimatter? Our universe is made of matter. Protons, neutrons, electrons. If a particle of matter meets its antimatter counterpart, they annihilate each other in a burst of pure energy. This is why we don't see large quantities of antimatter in our universe. It would have been annihilated in the early moments of the Big Bang. But what if the other universe was predominantly antimatter? The collision would be a cataclysmic event, a cosmic fireworks display of unimaginable proportions. Every atom in our universe would meet its antimatter twin from the other, and in a flash, everything would be converted into pure energy. Stars would vanish, galaxies would become brilliant points of light, and the very fabric of space-time would shimmer and then fade away. The collision would not be a slow, ponderous affair. It would be a sudden, violent erasure of both realities. This raises an interesting question. Is it possible that our universe has already collided with another one? Could the mysterious cold spots in the cosmic microwave background, CMB, the faint afterglow of the Big Bang, be a subtle scar from such an event? The CMB is a snapshot of our universe when it was just 380,000 years old. It's an almost perfectly uniform sea of microwave radiation, but with tiny fluctuations in temperature. Most of these fluctuations can be explained by our current models of cosmology, but a few particularly, some large cold spots, are harder to explain. Could they be the imprint of another universe, a bruise on the cosmic canvas left behind by a gentle grazing collision in the distant past? The idea is tantalizing. It suggests that the answers to our biggest cosmic questions might be right there in front of us, encoded in the ancient light of the universe's infancy. So we begin our journey tonight by simply asking, what if? What if the universe is not alone? What if it is but one piece of a much larger, more mysterious puzzle? We'll let our minds wander through the vastness of space, contemplating the possibility of other worlds and other realities, and what would happen if they were to meet ours. We will imagine this collision not as a disaster, but as a profound moment of cosmic truth. We'll explore it from a safe distance from our quiet, comfortable place in the here and now, and we'll let our imaginations be our guide. So close your eyes, take a deep breath, and let's drift into the cosmic night. Let's think about the Big Bang, not as a single event, but as a cosmic echo, and let's listen for the sound of another echo, another beginning reverberating in the darkness, the woven fabric of space-time. We now find ourselves standing on the edge of a new idea, the possibility of a cosmic neighbor. To truly understand what a collision might entail, we must first dive into the very architecture of our own universe, We need to go beyond the stars and galaxies and consider the stage upon which they perform their grand cosmic dance. This stage, this invisible theater, is what we call space-time. Imagine a vast, infinitely stretchy sheet of a material so fine it's almost transparent. Now imagine placing a heavy bowling ball in the center of the sheet. The ball doesn't just sit there. It creates a dent, a graceful curve in the fabric. This curve, this elegant distortion, is what we experience as gravity. It's not some mystical force pulling things together, but rather the geometry of the universe itself telling objects how to move. A smaller marble, rolling near the bowling ball, will follow the curve of the sheet, and we, from our limited perspective, would say the bowling ball is pulling the marble towards it. This is Einstein's profound and beautiful theory of general relativity, a concept that forever changed our understanding of the universe. So when we think about our universe, we should not just picture a collection of objects floating in a void. We should visualize a dynamic, four-dimensional tapestry, a woven fabric of 3 spatial dimensions, and one of time. The planets, stars, and galaxies are not just moving through this tapestry. They are actively shaping it, creating gentle curves and deep, profound wells of gravity. Our sun, for example, creates a gravity well that holds all the planets in our solar system in their orbits. The Milky Way galaxy creates a much larger, more subtle curve that keeps our solar system from flying off into the cosmic abyss. This intricate dance of mass and geometry is the reason we have stable planetary systems and spiral galaxies, the reason we have structure instead of chaos. It's an unspoken conversation between everything that exists and the space it occupies. This delicate balance, this perfect harmony, is what allows us to exist. Now let's bring our hypothetical second universe into this picture. If our universe is one great tapestry, then perhaps the other is another. Maybe it's a different color made of a different material with different properties. The two tapestries exist in a larger unknown space, a kind of meta-reality beyond our comprehension. In this larger space, they are simply 2 separate objects, 2 colossal cosmic sheets that are for some reason slowly drifting toward one another. The collision would not be a simple meeting of matter. It would be a collision of the fabrics themselves, a merging of 2 separate geometries. Imagine what that would be like. The very rules of space and time that govern our universe, the familiar curves and distances would begin to warp and distort as they came into contact with a different set of rules. This brings us to a deep and fundamental question about the nature of physics. Are the physical constants of our universe, the speed of light, the gravitational constant, the Planck constant, truly universal? Or are they just a local phenomenon, a particular setting chosen for our cosmic bubble? The truth is, we don't really know for sure. It's one of the great mysteries of modern science. Perhaps the other universe is a place where gravity is 10 times stronger. Its space-time would be incredibly warped with deep, steep gravity wells. A collision with our universe would be like a bowling ball hitting a gentle flat sheet. The gravity from the other universe would tear at our own pulling, at everything stars, planets, you and I, with an unimaginable force. Our entire universe would be stretched, compressed, and distorted in ways that are physically impossible to imagine. We would be a cosmic tug of war, and we would be on the losing side. But what if the opposite were true? What if the other universe had a much weaker gravitational pull? Its space-time would be almost flat, a calm, serene expanse. A collision would be a strange, almost gentle event. Our gravity wells, our planets and stars would be like powerful localized storms on their otherwise tranquil sea. The collision would create a ripple, a wave of disturbance that would travel through their universe and our own, like a stone dropped into a still pond. We would see our familiar tapestry of stars and galaxies begin to shimmer, to shake, as if a great hand were gently disturbing the entire sheet. The orbits of our planets would change, the paths of light would bend in new, impossible ways, and the very rhythm of time as we know it would be thrown into disarray. Let's think about the practicalities of this collision. The first contact wouldn't be a sudden dramatic explosion. It would be a subtle, almost imperceptible change at the boundary. Remember how we talked about the cosmic microwave background in the last part? That ancient light from the early universe. Imagine that as the very edge of our universe's influence. As the other universe with its own cosmic constants and geometry draws closer, it would begin to leave its mark on this ancient light. We might see a sudden inexplicable shift in the temperature of the CMB in one direction. We would see a large distinct bruise, a cold spot, or a hot spot that couldn't be explained by any of our current theories. It would be the cosmic equivalent of a gentle silent warning. It would be our universe whispering, something is coming. This raises an interesting philosophical question. Would we as a species even be capable of understanding this warning? Would we see it as a sign of an impending collision? Or would we simply write it off as an anomaly, a strange cosmic glitch that we will one day figure out? The most intriguing aspect of this is the idea of a cosmic string. A cosmic string is a hypothetical one-dimensional defect in the fabric of space-time created during the early universe. Think of it like a crack in a frozen pond. These strings are unimaginably dense and would have immense gravitational pull. They are a weird, beautiful part of physics, a theoretical possibility that we have yet to find evidence for. But what if a collision with another universe created such a string? What if the boundary where the two space-time tapestries meet is not a smooth merge, but a jagged, sharp tear? A cosmic string of unimaginable length and density. This string would stretch across our entire universe, cutting through galaxies, stars, and planets with no regard for their existence. The gravity of this string would be so powerful that it would tear apart anything that came near it. It would be a scar, a permanent reminder of the day our universe met its cosmic neighbor, a terrifying, beautiful monument to a meeting of worlds. And we, if we were lucky enough to even survive the initial encounter, would be living in a universe forever changed, forever scarred by this cosmic event, a ripple in the cosmic sea. Our journey has already taken us from the stillness of a potential cosmic birth to the profound geometry of space-time. We've imagined our universe as a vast woven tapestry, and we've speculated about another different tapestry approaching ours. But what is the force that would set this collision in motion? To answer that, we must travel back to the very first moments of our universe's existence, to a time when it was smaller than a single atom and undergoing a process so explosive, so counterintuitive, it almost defies belief. I'm talking about cosmic inflation, a theoretical period of extremely rapid exponential expansion that occurred just a tiny fraction of a second after the Big Bang. Imagine blowing up a balloon. At first it's small, and the markings you've made on it are close together. Then, as you blow, the balloon expands, and those markings fly apart from each other. Cosmic inflation was like that, but on a scale that makes a balloon seem like a speck of dust. In an instant, the universe expanded from something subatomic to something the size of a grapefruit, and then much, much larger. This period of rapid expansion solved many of the great puzzles of cosmology. It explains why our universe is so uniform, why it's so flat, and why it's so incredibly vast. The theory suggests that during this time, the universe was filled with a field of energy, a kind of cosmic potential that drove this expansion. Once this field decayed, the inflation stopped and the universe began its slower, more graceful expansion that we see today. But here's where things get interesting and a little bit strange. The theory of inflation, particularly a version known as eternal inflation, suggests that this process might not have been a one-time event. Imagine the cosmic potential field as a vast, frothing sea of energy. In some parts of this sea, the potential might decay, creating a bubble, a new universe like ours. But in other parts, the potential might not decay. It might continue to expand, creating more of the frothing sea, which in turn gives birth to more bubbles, more universes. It's a never-ending process, a cosmic engine for creating new realities. Our universe would just be one of these countless bubbles floating in an infinite, inflationary ocean. The beautiful poetic image here is that we are not alone. We are one of an endless silent legion of universes, each born from the same cosmic foam and each drifting in the darkness. So if our universe is a bubble and the other universe we're imagining is another, then a collision is not just possible, it's almost inevitable. In an infinite, eternal sea of inflation, these bubbles are born and they drift. Some drift away from each other, expanding into the vastness of the meta-reality. But some purely by chance will drift toward each other. Their boundaries, where the rules of their respective realities are defined, will eventually meet. This moment of first contact would be a fascinating and terrifying event. The cosmic scale is so immense that we wouldn't see it as a sudden crash. It would be a slow, ponderous approach, with the effects only becoming visible in our universe on the most ancient and grand scales. The very first sign might be a bubble nucleation event. This is a concept in quantum mechanics that describes the formation of a new phase in a system. Think of a supercooled liquid. It's below its freezing point, but it hasn't turned into a solid yet. Then a tiny impurity or a sudden disturbance causes a small crystal to form. That crystal then rapidly grows, and the liquid freezes. The collision of our universe with another would be like that. The vacuum of our universe, our own cosmic potential field, would be in a certain state. But as the other universe gets closer, its own potential field, its own vacuum, would begin to interact with ours. This interaction could cause our vacuum to become unstable, to decay into a new state. This decay would start at a single point and then expand at the speed of light, like a crystal forming in a supercooled liquid, rewriting the fundamental laws of physics as it goes. The strange and beautiful thing about this is that the change would be subtle at first. The boundary, the wall of this new changed reality, would move at the speed of light, so we couldn't outrun it. But it might not be immediately obvious that anything is wrong. Our universe's physical constants might be slightly different on the other side of this wall. The force of gravity might be a hair stronger, the speed of light a tiny bit slower. But our atoms would still hold together. Our stars would still burn, and our galaxies would still spin. We would simply be living in a slightly different universe without any immediate knowledge of the change. But as the wall continues to expand, it would eventually reach us, and the physical constants would change again, perhaps in a more dramatic way. And then again, and again. Our universe would be like a house of cards, slowly being dismantled and rebuilt over and over until the entire structure collapses. This raises another fascinating concept, the Novikov self-consistency principle. This principle from the world of theoretical physics suggests that if you could travel back in time, you couldn't do anything to change the past. It suggests that all events are self-consistent. The universe, in its own strange way, would conspire to prevent a paradox. This is a great example of a little-known scientific curiosity. But how would this principle apply to a universe collision? Would the universe, in its own strange way, prevent the collision from happening? Would the fundamental laws of physics somehow conspire to divert the two universes, or to prevent them from ever being born in the first place? The truth is, we don't really know for sure. The principle is a beautiful piece of theoretical conjecture, but we have no way of testing it. It's a philosophical puzzle, a cosmic riddle that reminds us that our understanding of reality is still so incredibly limited. The collision of these two bubbles would be the ultimate cosmic drama. Two bubbles born from the same cosmic foam, drifting for eons, and then at the end of their long journey, they meet. It is a story of chance, of inevitability, and of the profound mystery of existence. It is a reminder that we are not the center of the universe. We are simply one tiny piece of a cosmic tapestry, one small bubble in a vast frothing sea of possibilities. The ghost in the machine. Our journey so far has been one of imagining cosmic forces, of picturing great tapestries and foaming seas of potential. But to truly understand the nature of our universe and what another might bring, we must talk about the things we can't see. We must talk about the ghosts in our cosmic machine, dark matter and dark energy. When we look up at the night sky, everything we see, the stars, the planets, the nebulae, is only about 5% of the total stuff in the universe. The rest is invisible, a hidden architecture that shapes everything we know. About 27% is dark matter, and a staggering 68% is dark energy. We don't know what either of them are. They are a profound mystery, a cosmic whisper that we can't yet decipher. Dark matter, we believe, is a strange kind of particle that doesn't interact with light. We can't see it, we can't touch it, and we can't taste it. But we know it's there because of its gravitational pull. We see galaxies spinning so fast that they should fly apart, yet they hold together. The only way this makes sense is if there's a huge invisible halo of mass surrounding them, a halo of dark matter. It's the cosmic scaffolding on which galaxies are built, to the invisible glue that holds them together. It's a beautiful, unsettling thought that the vast majority of our universe is made of something we can't even perceive. It's like living in a house where the walls, the foundation, and the very air are all made of an invisible substance that we can only guess at from the way our furniture behaves. Dark energy, on the other hand, is even more mysterious. It's a repulsive force, a kind of anti-gravity that is accelerating the expansion of the universe. In the past, we thought the expansion of the universe might slow down or even reverse due to the gravitational pull of all the matter within it. But we've found the opposite is happening. The expansion is speeding up, and it's being driven by this strange, unknown energy. It's a force that is woven into the very fabric of space-time, and it's slowly but surely pushing everything further and further apart. The ultimate fate of our universe, we think, is to be a cold, dark, empty place with galaxies so far apart that the light from them will never reach us. This slow, lonely end is the ultimate consequence of dark energy. So what does this have to do with a universe collision? Well, what if the other universe is different? What if its dark matter and dark energy are not like ours? Maybe its dark matter is not made of the same particles as ours. Maybe they are more massive, or they interact in a different way. A collision would be like two invisible clouds of cosmic ghosts passing through one another. We wouldn't see the dark matter from the other universe, but we would feel it. We would feel its gravitational pull, its unseen hand tugging at our galaxies and stars. The orbits of our planets would change. The structure of our galaxy would be warped. It would be a profound, invisible disturbance, a cosmic earthquake that we could only measure by its effects on the things we can see. This raises a fascinating and unsettling question. Could a distant, invisible presence from another universe already be shaping our own right now? We wouldn't have any way of knowing for sure, but what if the other universe's dark energy is different? Dark energy, as we understand it, is a property of the vacuum of space itself. What if their vacuum has a different property, a different energy density? A collision would be a chaotic meeting of two different cosmic vacuums. The boundary between the two universes would be a place of immense pressure, a cosmic shockwave where the two different kinds of dark energy would meet. This would be a cataclysmic event, a collision not of matter, but of the very forces that shape reality. The dark energy from the other universe could be so much more powerful than ours that it would simply overwhelm us. Our universe and everything in it would be stretched and torn apart by this new, more powerful repulsive force. Galaxies would be ripped apart, stars would be vaporized, and the very atoms that make up our bodies would be pulled apart faster and faster, until nothing remained but a thin, tenuous soup of elementary particles, rushing away from each other at an ever-increasing speed. This brings to mind a little-known scientific fact, the Pioneer anomaly. For years, a number of spacecraft, including the Pioneer 10 and 11 probes, showed a small unexplained deviation in their trajectories. They were slowing down more than they should have been, and no one knew why. while the most likely explanation turned out to be a subtle thermal force from the probes themselves. The mystery of the anomaly captured the imagination of many scientists. It was a beautiful example of a strange, unexplainable quirk in our universe. Could such an anomaly, a tiny deviation in the motion of a spacecraft, be the very first sign of a collision with another universe? Could it be the first faint whisper of a different kind of gravity, or a different kind of dark matter from a neighboring cosmos? We don't have the answer to this question, but it's a beautiful poetic thought. It reminds us that the universe is full of mysteries and that we are still only just beginning to scratch the surface. So, as we imagine these two universes hurtling toward one another, let's remember that the most dramatic part of the collision might not be a brilliant flash of light or a thunderous roar. It might be a silent, invisible disturbance, a cosmic dance of ghosts. It might be a subtle shift in the gravitational pull of a distant star, or a tiny, inexplicable change in the way a galaxy rotates. It might be a quiet, unexplainable anomaly that we notice but can't quite decipher. It would be the universe whispering to us, telling us a secret that we're not yet ready to hear. The arrow of time's hesitation. We have contemplated the invisible ghosts of our universe and the possibility of other cosmic seas. Now, let's turn our attention to something even more fundamental, something that governs every moment of our existence: time. We experience time as a relentless forward march, an arrow that points in only one direction. We can remember the past, but we can't change it. We grow older, not younger. Coffee cools, never heats itself up. This one-way street of time is governed by a fundamental law of physics called entropy. In its simplest form, entropy is a measure of disorder. The universe left to its own devices tends toward greater disorder. A neat room naturally becomes messy. A dropped egg shatters, and you can't put it back together again. The expansion of our universe, the cooling of cosmic gases, and the eventual heat death of all things are all a consequence of this one simple law. The arrow of time and the increase of entropy are inextricably linked. But what if the other universe, the one on a collision course with ours, had a different arrow of time? This is a mind-bending concept, a philosophical puzzle wrapped in a physical impossibility. What if their universe was a place where entropy was decreasing? A place where rooms got neater by themselves, where broken eggs reassembled, and where time for them flowed backward, relative to ours. This isn't just a science fiction trope. It's a genuine, albeit highly speculative question in theoretical physics. The idea comes from the very early moments of the universe. In the Big Bang, the universe was in a state of incredibly low entropy. As it expanded and cooled, entropy increased, giving us the direction of time that we know. But what if in another cosmic bubble, the initial conditions were different, and the universe was born with high entropy? Could time in that universe flow backward as it moved toward a state of lower entropy? If such a universe existed and collided with ours, the consequences would be catastrophic and profoundly strange. The boundary between the two would not just be a meeting of different physical laws. It would be a meeting of two opposite flows of time. Imagine two rivers, one flowing upstream, the other downstream, and they crash into one another. What would happen at the point of contact? In our world, an object that crossed into their universe would begin to undo itself. A car would unrust. A person might begin to de-age their memories and experiences, unraveling backward. The atoms that make up our bodies would behave in impossible ways, their internal clocks ticking in reverse. It would be a place of beautiful chaos, a cosmic rewind button that would slowly, inexorably, begin to pull apart our universe. This is a terrifying and poetic thought, a world where our very sense of self, of identity, would be stripped away. The collision would also create a new shared boundary, where the law of entropy would be for a moment in flux. What would happen in this zone? Would time simply stop? Would it flow in two directions at once, creating a strange paradoxical temporal soup, where cause and effect lose all meaning? This is a question that our current understanding of physics simply cannot answer. It's a beautiful mystery, a paradox that reminds us that the universe is far stranger than we can possibly imagine. We would be a part of a cosmic dance, a chaotic waltz of two opposing temporalities where the rules of our existence are bent and broken in impossible ways. This brings to mind a little-known scientific curiosity, the twin paradox from Einstein's special relativity. The paradox states that if one twin travels to space at near the speed of light and returns, they will have aged less than their twin who stayed on Earth. The time dilation is real, a consequence of space-time's flexibility. It's a beautiful example of how time is not a constant, rigid thing, but a fluid woven part of the universe's fabric. Now imagine extending this paradox to an extreme. Instead of one twin aging slower, imagine an entire universe with a different temporal flow. It's a thought experiment on a cosmic scale, a beautiful mind-bending idea that helps us grapple with the profound and mysterious nature of time. So as we drift toward the potential collision, let's not just think about the stars and galaxies. Let's think about the very essence of what makes our universe the one-way arrow of time. Let's imagine what it would be like to stand at the boundary of two realities, one where time flows forward and one where it flows back. It would be a moment of cosmic revelation, a single instant where all the rules we've ever known, all the certainties of our lives would be called into question. It would be a moment of profound beauty and ultimate terror, and we would be there to witness it, if only in our minds. The quantum whisper of fate. Our minds have wandered through the grand designs of space-time and the relentless march of time's arrow. But now let's shrink our focus from the cosmic scale to something infinitesimally small. A place where the rules of our reality begin to bend and twist in beautiful and mysterious ways. We are entering the strange and beautiful world of quantum mechanics, the physics of the very small. In this world, particles like electrons and photons don't behave like tiny billiard balls. Instead, they exist in a cloud of probability, a haze of possibility. A single particle can be in many places at once, a concept known as superposition. It's only when we observe it, when we look at it, that the particle chooses a single state, a single reality from all the possible ones. The beautiful mind-bending idea here is that our act of observing a thing can in some way change its reality. This leads us to an even stranger concept entanglement. Imagine two particles, a pair of cosmic twins, are created together. They are intrinsically linked, no matter how far apart they are. If you measure the property of one particle, say its spin, you instantly know the spin of the other, even if it's on the other side of the universe. It's as if they are communicating with each other faster than the speed of light, a silent, instantaneous connection that defies our classical understanding of physics. We don't know why this happens. It's one of the great puzzles of quantum mechanics. It's a whisper in the cosmic dark, a hint that the universe is far more interconnected than we can possibly imagine. So how does this strange world of quantum mechanics relate to a universe collision? Well, think of the very first moment of contact between the two cosmic bubbles. It wouldn't be a dramatic, violent crash of matter. It would be a subtle, almost imperceptible meeting of quantum fields. The fundamental particles that make up our universe, the electrons, the quarks, the photons, are all just excitations in their respective quantum fields. The first point of contact between our universe and another would be a boundary where these two different quantum fields meet. The particles from our universe would begin to interact with the particles from theirs, and in this interaction, strange things would happen. For a brief fleeting moment, the particles at the boundary would exist in a state of quantum uncertainty. The laws of our universe would be in superposition with the laws of their universe. An electron might not just be an electron from our world. It might also be a particle from their world, a different kind of particle with different properties. It would be a cosmic paradox, a moment of beautiful chaos, where reality itself is in a state of flux. The rules that govern how particles behave, how they interact, how they create the atoms that make up our world, all of that would be up for grabs. This leads us to a fascinating and little-known scientific fact, the Casimir effect. The Casimir effect is a small but measurable attractive force that exists between two uncharged conductive plates in a vacuum. It's a direct consequence of quantum fluctuations of the virtual particles that are constantly popping in and out of existence in the empty space between the plates. Now imagine extending this concept to the collision of two universes. The boundary between the two would be a place of immense quantum fluctuations, a place where two different kinds of virtual particles are being born and dying in a cosmic dance. Could this interaction create a new kind of force, a cosmic Casimir effect that pulls the two universes together with an irresistible force? We don't know for sure, but it's a beautiful thought, a reminder that even the empty space between things is a bustling, dynamic place full of hidden energy and possibility. The collision in this view is not a single catastrophic event, but a slow, creeping quantum tide. It would begin at the edge of our universe with a single particle, a single photon from their universe, interacting with one from ours. This single interaction, this quantum whisper of fate, would then spread like a ripple in a cosmic pond across our entire universe. It would change the fundamental nature of our reality, one particle at a time, one interaction at a time, until our universe is no longer our universe, but something new, something different, something born from the quantum interplay of two worlds. The collision is not a cosmic war, but a gentle, silent merging of two realities, a dance of probabilities and possibilities on the smallest of scales, a shadow of a parallel self. From the silent whispers of quantum mechanics, we now expand our imagination once more, contemplating a grand and dizzying possibility. If a single particle can exist in a superposition of states in multiple realities at once, what about us? What about the universe itself? This is the core question behind the many worlds interpretation of quantum mechanics. The theory first proposed by Hugh Everett III suggests that every time a quantum measurement is made, every time a particle chooses a state, the universe splits. Every possible outcome of that measurement is real, each existing in its own separate but parallel universe. For every decision you've ever made, for every path you didn't take, there is a universe where you did. There is a universe where you are a poet, and one where you are an astronaut. There is a universe where you woke up 5 seconds later this morning, and another where you didn't. The beautiful and terrifying implication is that the cosmos isn't just one timeline, but a vast branching tree of infinite possibilities, and we are just one tiny fragile leaf on one of its many branches. The beauty of this idea is that it solves the paradox of superposition without having to resort to the idea that a conscious observer is required to collapse a quantum state. The particle doesn't choose a state, all the states are real, and the universe simply splits to accommodate them. But this theory also carries a heavy philosophical weight. It suggests that there is a version of you out there, a shadow of a parallel self, living in a different reality. This other you is not a ghost or a doppelganger. They are just as real, just as conscious, just as alive as you are. They are a different path that the universe took a different branch on the great cosmic tree. The truth is, we don't really know for sure if the many worlds interpretation is correct. It is a brilliant, unprovable idea, a beautiful mystery that reminds us that our understanding of reality is still in its infancy. So let's imagine our universe and the other universe on a collision course, both as part of this great cosmic tree. What if they are not just two separate bubbles, but two different branches, two different outcomes of a past quantum event? What if the other universe is a place where a small, seemingly insignificant choice was made differently? A universe where the cosmic constants are just a tiny bit different, where the initial conditions of the Big Bang were a hair warmer or colder. A collision between these two branches These two parallel realities would be a profoundly strange and unsettling event. It would not just be a merging of matter and energy, but a merging of histories. The collision would be the ultimate test of the many worlds interpretation. At the boundary, the two different realities would meet. The laws of physics from our universe would interact with the laws of their universe, and the two branches of the cosmic tree would begin to entangle. The beautiful and disturbing possibility is that the collision could cause a kind of quantum leakage. The information from their universe, the history of their reality, would begin to leak into ours and vice versa. We might start to see echoes of their world in ours. We might experience strange, inexplicable memories of things we never did, of people we never met, of places we've never been. These would not be ghosts or hallucinations. They would be real memories from our parallel selves, seeping through the collapsing boundary of the two universes. The collision would also be a cataclysmic event for the parallel selves. The other you out there, the one living in the other universe, would be just as aware of the collision as you would be. They would be a person with their own hopes and fears, their own loved ones and their own experiences, and they would be just as terrified by the prospect of a cosmic collision as we are. Their universe would be just as beautiful and just as precious to them as ours is to us. The collision would be a kind of cosmic fratricide, a killing of our parallel selves, and a destruction of their reality. It would be a moment of profound sadness and cosmic loss, a moment when all the possibilities of their world, all the decisions they made, all the lives they lived would be wiped away in an instant. This brings to mind a great scientific and philosophical paradox, Schrödinger's cat. It's a famous thought experiment that highlights the weirdness of quantum mechanics. A cat is placed in a box with a radioactive atom. If the atom decays, a hammer shatters a vial of poison and the cat dies. If the atom doesn't decay, the cat lives. According to superposition, until someone opens the box, the atom is both decayed and not decayed, meaning the cat is both dead and alive at the same time. The many worlds interpretation offers a simple, if mind-bending solution. When the box is opened, the universe splits. In one universe, the atom has decayed, the cat is dead, and we see it. In the other, the atom has not decayed, the cat is alive, and a different version of us sees that. Both realities are equally real. A collision of universes would be like opening the cosmic box. It would be the moment when two different realities, two different outcomes are forced to confront each other. And in that moment, all the beautiful, terrifying possibilities of the many worlds interpretation would come crashing down upon us. The symphony of gravity waves. We've drifted from the grand cosmic scale to the intimate strangeness of the quantum world and have even pondered the fate of our parallel selves. Now let's return to the macrocosm, but with a new instrument, a new way of listening to the universe. We've always seen the cosmos with our eyes, listening to it with our radios, but there is a deeper, more fundamental song being sung, one that is woven into the very fabric of space-time. I'm talking about gravitational waves, ripples in space-time itself, caused by the most violent and energetic events in the universe. Imagine the space-time tapestry we spoke of earlier as a perfectly still pond. Now imagine dropping two colossal stones into that pond, but instead of stones, they are two black holes spiraling toward each other at near the speed of light. The ripples they create are gravitational waves, and they travel outward at the speed of light, carrying with them a message from the deep cosmos. For a long time, these waves were a beautiful prediction of Einstein's theory of general relativity, but we didn't have the technology to detect them. They are so incredibly subtle, so gentle that we thought we might never be able to hear them. The ripples they create are so small that they would stretch or compress a meter-long ruler by less than the width of a single proton. But in 2015, we finally heard them. The LIGO experiment, a pair of giant detectors on opposite sides of the United States, heard the faint echo of two black holes colliding over 1 billion light-years away. It was a moment of profound cosmic revelation, a symphony from the stars, a new sense with which to perceive the universe. We had opened a new window into the cosmos, and we were finally able to listen to the silent screams of black holes colliding and the final death throes of giant stars. So what would happen if two universes were to collide? The collision wouldn't just be a merging of matter and energy. It would be a clash of two different spacetimes, two different cosmic fabrics. This would be the ultimate event for gravitational waves. A collision of universes would create a chorus of such waves, a cosmic scream that would reverberate across the cosmos. The waves wouldn't be from a single black hole collision or a single supernova. They would be from the collision of entire universes, from the merging of two different cosmic geometries. The ripples would be of unimaginable scale and power, tearing through our universe like a tsunami. The frequency of these waves would tell us something about the collision itself. High-frequency waves would be from small rapid events, like the collision of black holes. Low-frequency waves would be from much larger, more ponderous events, like the collision of galaxies. A universe collision would produce a wide range of frequencies, a complex and beautiful symphony that would tell the story of the two universes meeting. We might hear the high-frequency chirps of stars from the other universe colliding with ours, followed by the deep, low rumble of the galaxies themselves merging. It would be a cosmic symphony of chaos and creation, a beautiful and terrifying song that would play out across all of space-time. This brings to mind a little-known scientific fact, gravitational lensing. This is the bending of light by a massive object's gravity. The gravity of a galaxy, for example, can act like a giant lens bending the light from a more distant galaxy and creating a distorted, beautiful image. This is a beautiful, tangible example of the curvature of space-time. But what if a gravitational wave, a powerful ripple from a universe collision, were to pass through our solar system? The wave would bend the light from the sun, the stars, and the galaxies in a way that we could measure. The light would not just be bent, it would be stretched and compressed, creating a shimmering, distorted, and beautiful cosmic mirage. It would be a visual confirmation that a collision had happened, a cosmic fingerprint left behind on the fabric of space-time. The symphony of these waves would be a new kind of cosmic communication. It would be a language of gravity, a silent scream from the most cataclysmic event imaginable. We wouldn't hear it with our ears, but we would feel it with our detectors, and our understanding of the universe would be forever changed. It would be a moment when we finally listen to the cosmos, not just with our eyes, but with our very sense of being. The collision is not just an event. It is a profound message, a final beautiful song from a dying universe, and a birth cry from a new unknown one. The luminous veil of a new dawn. Our journey has carried us through the cosmic symphony of gravity, waves the invisible ballet of dark matter, and the mind-bending possibilities of parallel selves. Now, we arrive at the very moment of contact, the immediate aftermath of the cosmic collision. We have imagined the meeting of two great tapestries of space-time, the clash of two different sets of physical rules. But what would this look like? Not in the abstract, but in the raw, beautiful, and terrifying detail of a new cosmic dawn. The boundary between the two universes would not be a clean, distinct line. It would be a zone of unimaginable energy, a cosmic frontier where matter from our universe would meet matter from theirs, and in this meeting, something new would be born. Imagine a particle from our universe, say a simple proton, meeting a particle from their universe. The forces that hold that proton together, the strong nuclear force, the weak nuclear force, the electromagnetic force, they might all be different in the other universe. The particles from their world might be a different size, a different mass, or have a different charge. The collision of these two particles would not be a simple bounce. It would be a catastrophic event on a subatomic scale. The fundamental building blocks of both realities would be torn apart and reassembled in impossible ways. New, unimaginable forms of matter and energy would be created, particles that don't exist in our universe, particles that defy our understanding of physics. We would be witnessing the birth of a new kind of physics a new set of rules forged in the crucible of a cosmic collision. This boundary zone would be a place of unimaginable light and sound. The collision of matter and energy would release a brilliant flash of light, a luminous veil that would stretch across the cosmos. It would be a dawn unlike any other, a new light from a new reality. The light would not be the familiar light of stars or galaxies. It would be the light of creation itself, the raw energy of two universes colliding. And the sound, the silent sound of the collision would be carried on the gravitational waves we spoke of earlier, a cosmic scream that would reverberate across all of space-time. It would be a moment of cosmic revelation, a single instant where all the rules we've ever known, all the certainties of our lives would be called into question. The beautiful and disturbing possibility is that the collision could create a new kind of baryon asymmetry. Baryons are the particles that make up most of the matter in our universe, like protons and neutrons. In the very early universe, there was a slight imbalance between matter and antimatter, a tiny excess of matter that survived the initial annihilation and went on to form everything we see today. It's a fundamental mystery of our universe, a subtle, beautiful asymmetry that allowed us to exist. But what if the other universe had a different asymmetry? What if it was dominated by antimatter? The collision would be a cataclysmic event, a cosmic fireworks display of unimaginable proportions. Every atom in our universe would meet its antimatter twin from the other, and in a flash, everything would be converted into pure energy. It would be the ultimate cosmic erasure, a sudden violent end to both realities. But what if the other universe was made of matter, but with a different set of properties? The collision would be a chaotic meeting of two different kinds of matter. The protons and neutrons from our universe would interact with the protons and neutrons from theirs, creating a strange new kind of matter that would be a hybrid of both. This new matter would have different properties, different mass, and different interactions. It would be an exotic transient form of matter, a beautiful and impossible creation that would only exist in the boundary zone of the two universes. This brings to mind a little-known scientific fact: proton decay. According to some grand unified theories of physics, protons, the stable building blocks of our universe, should eventually decay into smaller particles. The decay is so slow that we have never observed it. But if it's real, it means that even the most fundamental building blocks of our reality are not permanent. Now imagine a universe collision. The boundary zone would be a place where the stability of protons is called into question. The interaction with matter from the other universe could cause our protons to decay at a much faster rate, to simply vanish in a puff of pure energy. It would be a quiet, silent decay, a slow, imperceptible unraveling of our reality, one proton at a time. It would be a beautiful and terrifying thought, a reminder that even the most stable things in our universe are fragile and temporary. So as we contemplate this collision, let's not just think of it as a moment of destruction. Let's also think of it as a moment of creation, a new dawn forged in the crucible of two colliding worlds. It would be a moment when all the rules we know are broken and a new, more beautiful and more mysterious set of rules are born. It would be a moment of cosmic poetry, a luminous veil of new light and a new reality, a beautiful and terrifying beginning to an unknown end, the unraveling of the familiar. We have just witnessed in our mind's eye the birth of a new reality at the cosmic boundary. But what does this mean for our own familiar universe? The rules that govern our existence, the forces that hold everything together, are so precisely balanced that if even one of them were slightly different, we wouldn't be here. The delicate equilibrium of the cosmos would be shattered. I'm talking about the four fundamental forces of nature: the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. These are the four pillars upon which our universe is built, and a collision with another universe could very well be the cosmic earthquake that brings them all crashing down. Let's consider the strong nuclear force. This is the incredibly powerful force that binds protons and neutrons together in the nucleus of an atom. Without it, the positively charged protons would fly apart, repelling each other with immense force. No atoms would exist, no stars would burn, and no life would ever have a chance to form. Now imagine the other universe has a slightly weaker strong nuclear force. The collision would be a chaotic meeting of two different kinds of atomic nuclei. The nuclei from our universe, held together by a strong force, would meet nuclei from their universe held together by a weaker one. The boundary zone would be a place where the stability of our atoms is called into question. Our protons and neutrons would begin to feel the pull of this weaker force, and in some cases, our atoms would simply fly apart, dissolving into a soup of elementary particles. It would be a slow, silent disintegration, an unraveling of the familiar atomic structures that make up our world. Then there is the weak nuclear force, the force responsible for radioactive decay. It is a beautiful and mysterious force, and it is essential for the process of nuclear fusion in the sun, which is what gives us light and warmth. What if the other universe had a different weak force, one that was either much stronger or much weaker than ours? A stronger weak force might cause our atoms to decay at an accelerated rate. The very building blocks of our reality would become unstable, and our universe would become a hot, radioactive mess. A weaker weak force might prevent nuclear fusion from happening at all, and our sun and all the stars in our universe would simply go out, plunging the cosmos into an eternal darkness. It would be a quiet, unceremonious death, a slow fade to black. The electromagnetic force is the force that holds atoms and molecules together, the force that gives us light and electricity. It's the reason we can see and touch the world around us. What if the other universe had a different electromagnetic force? What if their fundamental electric charge was slightly different? The collision would be a meeting of two different kinds of light, two different kinds of electromagnetism. The very fabric of light would be torn apart and reassembled in impossible ways. The stars from our universe would emit light that is unrecognizable to the stars from theirs, and vice versa. It would be a visual paradox, a cosmic mirage, where the light from the two universes would create a strange, shimmering veil that would stretch across the cosmos. And finally, there is gravity. The force we have talked about so much already. Gravity is the gentle hand that guides the stars and galaxies, the sculptor of space-time itself. What if the other universe had a different gravitational constant, a different strength of gravity? The collision would be a catastrophic clash of two different gravitational potentials, a cosmic earthquake that would rip apart the very structure of our universe. Galaxies would be torn apart, stars would be flung out into the void, and our solar system would be a tiny fragile ship in a cosmic storm of unimaginable power. This brings to mind a little-known scientific fact, the fine structure constant. This is a fundamental constant of physics that determines the strength of the electromagnetic interaction. It's a dimensionless number, meaning it has no units, and its value is approximately 1D137. This number is so precisely tuned that if it were even slightly different, atoms would not be able to form, and life as we know it would be impossible. It's a beautiful example of the delicate balance of our universe. Now imagine a collision with another universe where the fine structure constant is different. The collision would be a direct attack on the very structure of our atoms. Our electromagnetic force would become unstable, and our universe would begin to unravel one atom at a time. It's a beautiful and terrifying thought, a reminder that the universe is a fragile temporary thing, and that we are a part of a cosmic dance that is far more complex than we can possibly imagine. Echoes of a dying star. We have imagined the unraveling of the very forces that hold our universe together. But let's bring our focus back to a more tangible, more beautiful. Cosmic dance, the life and death of stars. Our universe is a tapestry woven from the light of billions of suns, each a brilliant point of light, burning in the dark. These stars are not permanent. They are born in vast, swirling clouds of gas and dust called nebulae, and they live for billions or even trillions of years, fusing hydrogen into helium and other heavier elements. And then, at the end of their lives, they die. A small star like our sun will gently fade into a white dwarf, a beautiful, dense cosmic ember. A massive star, however, will go out in a spectacular, violent explosion called a supernova, seeding the cosmos with the heavy elements that make up planets and even us. It is a beautiful cyclical process, a cosmic echo of creation and destruction. Now imagine this beautiful, delicate cosmic dance being interrupted by a collision with another universe. The stars from our universe would meet the stars from theirs, and in this meeting, all the rules we know about stellar evolution would be thrown out the window. A star from our universe, burning with the familiar physics of our world, would meet a star from their universe burning with a different set of rules. The collision would not be a simple crash. The two stars would not just explode. The collision would be a cataclysmic event, on a cosmic scale, a moment where the very fabric of two stars is torn apart and reassembled in impossible ways. The matter from our star would interact with the matter from their star, creating new, strange, and exotic forms of matter that defy our understanding of physics. The collision of two stars, two beautiful burning cosmic beacons, would be a moment of profound cosmic tragedy. The light from their collision would be unlike anything we have ever seen. It would be the light of two different realities, two different sets of physical rules meeting in a single brilliant flash. The light would not be a single color, but a beautiful shimmering tapestry of all the colors of both universes. It would be a visual paradox, a cosmic mirage where the light from the two stars would create a strange, beautiful, and impossible spectacle. But what would happen after the initial collision? The debris from the two stars would not just fly apart. The matter would be compressed to an unimaginable density, creating something new and terrifying. It could be a new kind of black hole, a singularity with a different set of properties than the black holes in our universe. It could be a new kind of neutron star, a dense, pulsating cosmic heart with a different rhythm than the ones we know. It could be a new kind of matter entirely, a strange, exotic substance that only exists in the boundary zone of the two universes. This brings to mind a little-known scientific fact: pulsars. A pulsar is a highly magnetized rotating neutron star that emits a beam of electromagnetic radiation. We can detect these beams as pulses of light every time the star's rotation sweeps the beam past Earth. They are the beautiful ticking cosmic clocks of our universe. Now imagine a collision with another universe. What if their pulsars have a different rhythm, a different frequency? What if their pulsars don't emit light but something else entirely? The collision would be a chaotic meeting of two different kinds of pulsars, a cosmic drum solo where the rhythms of the two universes would clash and create a strange, beautiful, and impossible song. It would be a moment when our familiar cosmic music is replaced by a strange, new, and beautiful symphony of chaos and creation. The echoes of these dying stars would be the final beautiful song of a universe that is no longer our own. It would be a song of destruction and creation, a song of chaos and order, a song of life and death. It would be a song that reminds us that the universe is not a permanent, unchanging thing. It is a dynamic, living and breathing thing that is constantly in a state of change. And in this moment of profound cosmic change, we would be there to witness it, if only in our minds. The memory of light's first breath. We have imagined the life and death of stars in this cosmic collision. Now let's go even further back in time to the very first moments of our universe's existence. We must talk about the cosmic microwave background, CMB, the oldest light in our universe, the faint afterglow of the Big Bang itself. When our universe was just 380,000 years old, it was a hot, dense plasma, an opaque fog of particles. As it expanded and cooled, it reached a point where electrons could finally combine with protons and neutrons to form the first atoms. At that moment, the universe became transparent, and the light from that initial flash was free to travel. That light stretched and cooled by the expansion of the universe over 13.8 billion years is what we now see as the CMB. It is a snapshot of our universe in its infancy, a cosmic baby picture that holds the secrets of our origins. The CMB is almost perfectly uniform, a testament to the incredible smoothness of the early universe. But it is not perfectly uniform. It has tiny temperature fluctuations, small hot spots and cold spots that represent the subtle density variations in the early universe. These tiny variations, these cosmic seeds, grew over billions of years into the galaxies and galaxy clusters we see today. The beautiful and poetic idea here is that the large-scale structure of our universe, the cosmic web of galaxies, is a direct consequence of the tiny, almost imperceptible wrinkles in the CMB. We are in a very real way the children of those ancient cosmic wrinkles. Now imagine our universe on a collision course with another. What would a collision do to this ancient, beautiful light? The collision wouldn't just be a localized event. It would be a cataclysmic event on a cosmic scale, a moment where the very fabric of our universe is torn apart. The gravitational waves we spoke of earlier, the silent screams of two universes colliding, would leave their mark on the CMB. The light would be stretched and compressed in new and impossible ways, creating a pattern of hot and cold spots that we would have a very hard time explaining with our current theories. It would be a cosmic bruise, an indelible scar on the ancient tapestry of our universe. This brings to mind a little-known scientific fact, the Sachs-Wolf effect. This is a beautiful piece of cosmology that explains how the light from the CMB can be affected by the gravity of the galaxies it passes through. As the light from the CMB travels toward us, it has to climb out of the gravity wells of galaxies and galaxy clusters. This costs it energy, and so the light is slightly redshifted or cooled. The more massive the galaxy, the bigger the effect. The Sachs-Wolf effect is one of the beautiful ways that we can see the invisible hand of gravity shaping our universe. Now imagine a collision with another universe. The gravity from the other universe would not just be a localized event. It would be a cosmic tug-of-war, a powerful invisible hand pulling at the very fabric of our universe. The Sachs-Wolf effect would be magnified to an unimaginable degree. The light from the CMB would be stretched and compressed in new and impossible ways, creating a beautiful and terrifying pattern of hot and cold spots that would be a direct consequence of the collision. The bruise left behind on the CMB by a collision would be a cosmic fingerprint. It would tell us something about the other universe, about its mass, its density, and its geometry. We would be able to read the history of the collision in the light of the universe's infancy. It would be a moment when we finally have tangible evidence of a multiverse, a moment when our beautiful speculative theories are confirmed by a single beautiful scar on the face of the cosmos. The memory of this light, this ancient, beautiful whisper from the beginning of time, would be forever changed. It would no longer be just a memory of our own universe's birth. It would be a memory of a cosmic meeting, a beautiful and terrifying story of two universes that met and changed each other forever. It would be a story that we could read in the light of the cosmos, a story that would forever remind us of our place in a beautiful, strange, and mysterious multiverse. The paradox of the observer. We have traveled through the cosmic history of our universe, from its first light to the echoes of its dying stars, all through the lens of a potential collision. Now, we must ask a question that is both scientific and deeply philosophical. Could we even exist to witness such an event? This brings us to the anthropic principle, a beautiful and unsettling idea that suggests the universe's fundamental constants and laws are precisely the way they are, because if they were any different, we wouldn't be here to observe them. Think of the universe as a giant cosmic lottery. We won the lottery of existence Because the numbers, the speed of light, the strength of gravity, the mass of an electron came up just right. If the fine structure constant we discussed earlier was even slightly different, atoms wouldn't be able to form, and there would be no life. If gravity were a little stronger, stars would burn out too quickly. If it were a little weaker, galaxies wouldn't form. We exist in a universe that is a perfect, beautiful cosmic accident, a place where all the pieces fit together, just so to allow for the possibility of life. This is a beautiful and humbling thought. It suggests that our existence is not just a random event, but a profound consequence of the universe's fundamental architecture. It's a cosmic riddle, a chicken and egg question. Does the universe have its properties because we are here to observe them? Or are we here because the universe has its properties? The truth is, we don't really know for sure. It's one of the great mysteries of science, a question that lies at the intersection of physics and philosophy. So what does this have to do with a universe collision? A collision with another universe would be the ultimate test of the anthropic principle. The collision would be a chaotic meeting of two different cosmic architectures, a moment where the delicate balance of our universe's constants and laws would be thrown into disarray. The new combined universe would not be a stable, predictable place. It would be a place where the laws of physics are in flux, where the fundamental constants are constantly changing, and where the possibility of life as we know it would be non-existent. We would be a tiny, fragile speck of dust in a cosmic hurricane of unimaginable power. The beautiful and terrifying possibility is that the collision would be a kind of cosmic reset. The combined universe would not be a place where life could exist. It would be a place of raw, unadulterated energy, a place where the laws of physics are in a state of beautiful chaos. The universe, in its own strange way, would be going back to a state of high entropy, a state of maximum disorder. It would be a new beginning, a new Big Bang, but one that is not conducive to life. The collision would be a profound moment of cosmic truth, a single instant where all the beautiful, improbable coincidences that allowed us to exist would be undone. This brings to mind a little-known scientific curiosity, the Fermi paradox. The paradox, named after physicist Enrico Fermi, asks a simple, beautiful question. If the universe is so old and so vast, and if there are so many stars and so many planets, then why haven't we seen any evidence of other intelligent life? The silence of the cosmos is one of the most profound and unsettling mysteries of our time. One of the many possible explanations for this paradox is the Great Filter hypothesis, which suggests that there is a step in the evolution of life that is so difficult to pass that it is a barrier for almost all intelligent species. A universe collision could be a great filter, a cosmic event so cataclysmic that it would wipe out any intelligent life that exists. And it would be a permanent, beautiful, and terrifying reminder of our fragility. It's a beautiful and unsettling thought, a reminder that we are not the masters of our own destiny, but a tiny, fragile piece of a cosmic puzzle that is far larger and far more mysterious than we can possibly imagine. The silent scream of black holes. We have contemplated the paradox of our own existence and the delicate cosmic balance that allows for it. Now let's turn our attention to the most mysterious and profound objects in our universe, black holes. A black hole is not a hole at all, but an object with such immense gravity that nothing, not even light, can escape its pull. It is a cosmic point of no return, a place where all the laws of physics as we know them break down. The boundary of a black hole, the point at which nothing can escape, is called the event horizon. Once you cross the event horizon, you are on a one-way trip to the singularity at the center, a point of infinite density where all the mass of the black hole is concentrated. It is a beautiful and terrifying thought that there are places in our universe where space and time are so warped that they cease to have any meaning. But what would happen if a universe collision were to occur and two black holes, one from each universe, were to meet? This would not be a simple meeting of two massive objects. It would be a cataclysmic event on a cosmic scale, a moment where the very fabric of two different spacetimes is torn apart. The black hole from our universe with its familiar event horizon and its singularity would meet a black hole from their universe with its own set of properties. The collision would be a chaotic meeting of two different kinds of gravity, two different kinds of singularities. The beautiful and disturbing possibility is that the collision could create a new kind of black hole, a cosmic monstrosity with a different set of properties than the ones we know. The two singularities would not just merge, they would clash, creating a new, more powerful singularity that would be a hybrid of both. This new singularity would have a different set of properties, a different mass, and a different kind of event horizon. It would be a new kind of cosmic monster, a beautiful and terrifying creation that would only exist in the boundary zone of the two universes. The collision of these two black holes would also produce a powerful burst of gravitational waves, a silent scream that would reverberate across all of space-time. The waves would be of an unimaginable scale and power, tearing through our universe like a tsunami. We would be able to hear the chirp of the two black holes as they spiral toward each other, a sound that would tell us a beautiful and terrifying story of a cosmic collision. The chirp would be a new kind of cosmic communication, a silent message from the most cataclysmic event imaginable. It would be a moment when we finally listen to the cosmos, not just with our eyes, but with our very sense of being. This brings to mind a little-known scientific fact, the no-hair theorem. This is a beautiful piece of black hole theory that suggests that a black hole can be completely described by only three external properties: its mass, its electric charge, and its angular momentum. The theorem suggests that all other information about the matter that fell into the black hole is lost. It's a beautiful and unsettling idea, a reminder that there are places in our universe where information can simply vanish. Now imagine a collision with another universe. What if their black holes don't follow the no-hair theorem? What if they have other properties, other kinds of hair that we can't even imagine? The collision would be a chaotic meeting of two different kinds of information, a moment where all the beautiful certainties of our black hole physics are called into question. It would be a beautiful and terrifying thought, a reminder that the universe is a far stranger and more mysterious place than we can possibly imagine. The silent scream of these black holes would be the final beautiful song of a universe that is no longer our own. It would be a song of destruction and creation, a song of chaos and order, a song of life and death. It would be a song that reminds us that the universe is not a permanent, unchanging thing. It is a dynamic, living and breathing thing that is constantly in a state of change. And in this moment of profound cosmic change, we would be there to witness it, if only in our minds. The gentle dissolution of all things. We have journeyed to the edge of reality, contemplated the silent scream of colliding black holes, and imagined a universe unraveling at its very seams. Our cosmic adventure has been one of great chaos and beautiful destruction. But what is the ultimate fate of this combined chaotic universe? The collision would not be a permanent state of high energy and violence. The universe, in its own strange way, always seeks equilibrium. It always seeks a state of rest, a state of peace. And so the ultimate fate of this new combined universe would be a slow, gentle dissolution of all things, a beautiful, peaceful end to a beautiful, violent story. Imagine the new combined universe, a place of beautiful chaos and unimaginable energy. The light from the colliding stars, the gravitational waves from the merging black holes, the new exotic forms of matter, all of it, would not last forever. The universe would begin to expand, driven by the dark energy that we spoke of earlier, but a different kind of dark energy, a new, more powerful force that was forged in the crucible of the collision. This new dark energy would push everything further and further apart, stretching space-time and cooling the universe to an unimaginable degree. The stars would burn out, the galaxies would drift into the cosmic void, and the universe would become a cold, dark, and lonely place. The new exotic forms of matter that were created in the collision would be unstable. They would decay into more familiar particles, and those particles would eventually decay into nothingness. The protons that make up our bodies, the very building blocks of our reality, would begin to decay slowly, imperceptibly, until nothing remained but a thin, tenuous soup of elementary particles rushing away from each other at an ever-increasing speed. It would be a quiet, unceremonious death, a slow fade to black. The universe would be a place of pure entropy, a place of maximum disorder, and in that disorder, there would be a kind of peace. The combined universe would not be a permanent thing. It would be a transient state of being a beautiful, violent dream that would eventually end. The universe, in its own strange way, would be going back to a state of high entropy, a state of maximum disorder. It would be a new beginning, a new Big Bang, but one that is not conducive to life. The collision would be a profound moment of cosmic truth, a single instant where all the beautiful, improbable coincidences that allowed us to exist would be undone. The universe would be a place of raw, unadulterated energy, a place where the laws of physics are in a state of beautiful chaos, and in that chaos, there would be a kind of beauty. The beautiful and terrifying paradox of the end of the universe is that in its death, there is a kind of peace. The universe, like a tired old giant, would slowly, gently close its eyes and drift into an eternal sleep. The stars would go out, the galaxies would fade away, and the universe would become a place of pure silence, a place of pure darkness. It would be a beautiful and terrible end, a final peaceful song from a universe that is no longer our own. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing? The journey we have taken tonight has been a long and strange one, from the stillness of a potential cosmic birth to the beautiful, peaceful end of all things. We have been to the edge of reality, and we have returned. The universe we have imagined is a place of beautiful chaos and unimaginable power, but it is also a place of peace, a place of quiet, a place of gentle dissolution. The stories we have told are not just stories about the universe. They are stories about us, about our place in the cosmos, about our beautiful, fragile, and temporary existence. Before you drift off, just allow these final thoughts to gently brush past you. Let them slowly fade as a whisper into the quiet of your room. Remember that even in the greatest cosmic collision, there is a kind of strange peace. The universe is a place of beautiful paradoxes, a place where life and death, order and chaos are all a part of a beautiful, endless dance. And now, my friend, the dance is over for tonight. Sleep well, my companion. Wherever and whenever you are, sweet dreams.